Hello class, this is going to be our first session of homework online. I'll basically do the homework with you and we'll record it and post it on YouTube. Obviously, if you're listening to this, you already know it's on YouTube. All right, so let's start with question 1. Question 1A, it says state whether each set of ordered pairs represents a function. Now, what does that mean? I have a set, and the set basically represents those brackets right there. And I have ordered pairs, which is basically points 2, 3. I have the point 3, 4. I have the point 4, 5. 5, 6. And I have the point 6, 7. And then that's my set. Okay, all of it's a function defined within a set. It's basically a bunch of relationships. What does that mean? When x is 2, y is 3. So that's my 1 point. When x is 3, y is 4. So when x is 3, y is 4. When x is 4, y is 5. That's my point right there. When x is 5, y is 6. And when x is 6, y is 7. And this basically represents my relationship. Now, what makes it a function or not depends on if for every x value, for each x, these are my x values right here. I have x equals, what's going on? If I have x equals 2, x equals 3, x equals 4, x equals 5, x equals 6, if there's only one value at these x values, then I have a function. Function. So 1a is a function. All right. Let's look at 1b. So we're doing 1b now. Okay. And let's erase everything here. And what we're going to do is we're going to we're going to put everything down, all our points. We're going to mark our points. So it's a set. Five, -3. So it's 5, -3. And then we have 6 minus 4. 6 minus 4. And then we have 7, -5. 7, -5. And then we have 8 minus 6. 8 minus 6. Close my set. This, once again, is a relationship between x and y values. When x is 5, y is -3. When x is 6, y is -4. And so on and so forth. And when we graph them, we have to ask ourselves if for every x value, we have only one y value. If that's true, then it's a function. So once again, 1b is a function. So basically you do this for all of them until you get to, you keep doing that, and that's how you determine if it's a function. Now let's do an example where it turns out that the relationship is not a function. And how do we determine that? Okay, so let's, I'll just do one example. Okay, so we're going to do D. And For D, we have a set of ordered pairs, 6, 3, 7, 3, 8, 3, and that's my whole set. So if I graph it, 6, 3 would be there, 7, 3, 7, 3, 7, 3 would be there. And then finally, 8, 3 would be there. Now, it's important to note that for every x value, there's only one y value, which means this is also a function. Okay, so you got to be careful. Like, x's can refer to the same y value, but what makes something not a function is if for one x value you have multiple y values. So D is a function. Let's try one more as an example of not a function. Let's see if we can find one that's not a function. So I'm going to try f. So f is the following. Oh, for God's sakes, work. F, whoops, erase. Let's try this again. F, it's a set of ordered pairs. One of the ordered pairs is 5, 4. The next one is 5, 5. The next one is 5, 6. The next one is 5, 7. So let's check this out. So the first one is 5, 4, then followed by 5, 5, then 5, 6, then 5, 7. Okay, if we look at this, we see that for the x value 5, there's 4 possible solutions. So this means it's not a function. And the way you look at functions is it's like a map. Okay, it's like if you're at 5, the value is one number. Now, if there's multiple numbers, then you don't know where to go when you're 5. It could be at 5, y could be 4, 5, 6, or 7. That whole setup makes it not a function. Okay, do the rest of the questions on your own and ask questions if you have any.